So the first example of when the environment may influence epigenetic control in humans that we'd like to talk about is the Dutch Famine. So this was a famine that's variably called the Dutch Famine or the Dutch Hunger Winter that occurred through the later part of 1944 through to May 1945. So this was during the end of the Second World War. And it happened because there was a German blockade of supplies into the Western Netherlands. And then once that blockade was relieved in about November of 1944, there was a very harsh winter that had already set in. And so then this region was isolated anyway because of the harsh winter, and they weren't able to get food supplies in appropriately. So because of this particular period, it was a period of about 9 or 10 months of very low food supply, the number of calories that each adult had per day dwindled from about 1,000 calories at the beginning of the famine through to 580 calories a day towards the end of the famine. So at the moment, the average recommended caloric intake for an adult is 1,800 calories, at least in Australia. So you can see down at 580 calories, it's a lot less. In the end, the only thing that they had in their rations was, for a whole week for an adult, was 400 grams of bread, that's less than a loaf of bread, and 1 kilogram of potatoes, so very little food. And you can see here a picture of two people pushing a trolley of food, and they'd obviously obtained from somewhere, whether it was their rations or something else. So this period was an extremely hard period for these people in terms of their food supply. It was a really serious famine, and they actually even resorted to eating the bulbs, so eating those tulip bulbs that we saw the beautiful pictures of the flowering tulips in the previous in the previous lecture. So the reason that it ended in May 1945 was because Western Netherlands was liberated. And around this time there were airdrops from the Royal Air Force, so the British Royal Air Force, and this was called Operation Manna, and there were also supplies sent through from Sweden, and people called this Swedish bread because there was grain sent through from Sweden. And the Dutch people living in this area at the time were so relieved that they actually, you can see in this image that I've got here, hopefully you can see that they have spelt out in tulips, many thanks in tulips, because they were so grateful for the food supplies that were finally sent through. They were really, really suffering. So I don't know if you can see the many thanks, but it's here saying many thanks in tulips, which I think is a nice image from an air shot at that time. So after this period then, they embarked upon the Dutch Famine birth cohort study. And what they wanted to know was what were the consequences of having this extreme period of famine for these people. And what the results seemed to show was that extreme famine, this famine experienced during the periconceptual period, so this is the period for just before gestation, so just before conception through early development, had an adverse effect on the offspring. So of course these babies were, as you might expect, low birth weight, and then when you went on to look at how they developed into later life, they were more likely to develop diabetes and chronic vascular disease and obesity, and so this was because of altered glucose tolerance. But there were also other phenotypes which they displayed at a higher incidence than control people that hadn't experienced this famine, and that was increased mental and metabolic disorders as well. So the controls that they had in this case were children that were born to the same parents that were conceived in periods that weren't this terrible famine. But they also had the controls where the famine was at a different period of gestation. So if you experienced this famine throughout gestation but not that periconceptional period, for example, or perhaps later after the baby was born, these didn't seem to have this adverse, the correlation with increased incidence of disease or shorter longevity because of obesity and diabetes, as it did during this periconceptional period. So this is probably still quite controversial because it's difficult to imagine with this long famine how you could have only experienced famine for the periconceptional period. If this was true, then you would imagine it would have to be right at the very end of the famine, but then of course the mother would have had famine for all of that preceding period. But apparently this is the case. So even in this study, a very good study, it's still relatively controversial. So this periconceptional period, if you think about it, actually aligns with one of those sensitive periods we spoke about in the last lecture. So it aligns nicely with when the gametes are undergoing their final stage of maturation, the ones that will actually go on to form the baby, and of course this early pre-implantation and early post-implantation development in the embryo, when we know there's this active remodeling. So they've done some studies now to look at what would the molecular basis of this altered longevity in the children be. And they can find, associated with this increased disease propensity, they can find altered DNA methylation at a small handful of genes. So it's a relatively subtle difference in DNA methylation, but the difference in DNA methylation happens at 3 imprinted genes, so IGF2, GNAS and MEG, and at those imprint control regions, as well as some other metabolic genes. Now, this is interesting, I think, if we think back to what I was talking about in week 4, where the influence of the environment happened on the imprinted genes, and this is why there seems to be an increased risk of imprinting disorders following IVF or other assisted reproductive technologies. And here again, it's the imprinted genes which appear to be affected. So perhaps it's these class of genes which might be more sensitive than other parts of the genome. So there is some molecular evidence for epigenetic changes with this change in diet in the Dutch famine. So the original data coming out of these studies suggested that perhaps there was some transgenerational aspect. In other words, if you considered the subsequent generations of these babies that during conception were exposed to a very low caloric intake with their mothers, maybe there was going to affect many generations to come. But actually, once the follow-up studies have been done with a much better controlled cohort, in other words, in this case, they had much better accurate measures of birth weight, there doesn't in fact appear to be any transgenerational aspect. So rather, it's just that exposure during that critical window appears to alter the offspring health. So the Dutch famine, along with other data as well, led to a new hypothesis. I mean, this is the developmental origins of adult health and disease hypothesis, or many people call this DOHAD. So it used to be called the Barker hypothesis because Barker proposed it originally. And this is used as a way to explain how it could be that you can have such long-term consequences based on changes that occurred in the in utero or neonatal environment. So you can have long-term consequences which will alter your health as an adult. So we know that, as I just said, in the Dutch famine, this undernutrition then resulted in consequent obesity and diabetes, or an increased incidence of diabetes, type 2 diabetes and obesity in the offspring, along with other things. There's some separate evidence for relating to hypertension. And what's interesting is that the effect on for obesity and diabetes is actually exacerbated if the diet in the adults is actually one of plenty. So in other words, if there's plenty of food around once you're born and when you're a child and an adult. And this in a way makes sense that of course you're going to be more likely to be able to become obese or get type 2 diabetes if the food is plentiful. But because of this idea that you had a restricted food supply in utero, then leading to the fact that you become an obese and diabetic adult, this has been also called the thrifty phenotype hypothesis. So if you experience this period where you didn't get enough food, your body learned, perhaps epigenetically learned, to store energy away really well. And therefore, when food is no longer scarce, but is actually in great supply, then you'll still store food away because you're worried that this period of famine might happen again, or your body is aware that this could happen. So it's been proposed that these sorts of programming events, this programming of how your body's metabolism might be set up, could have some epigenetic basis. And as I said, there's some molecular evidence that DNA methylation is altered in the children born in the Dutch famine. But so far, the jury is still out. Now, this is a really interesting concept that in utero, what happens to you in utero will have lifelong consequences and will actually could influence whether or not you get type 2 diabetes, maybe in your 50s. And so, of course, it's a very important thing for us to think about in terms of human health. We need to work out how this is happening, if it is indeed happening, and address it appropriately, because it will alter the health of the next generation for a very long period, and so has very long-term consequences that we need to think about. In the next lecture, we're going to think about a second example of how diet in a human cohort or cohorts seems to relate to their phenotype later on.